Alrighty, gang, we're going to show that the melting of water is spontaneous at 25 degrees Celsius and 1 bar. And I did this a few different ways. Other methods are in the description, but in this video, we're going to determine that it's spontaneous by using the fundamental equation of chemical thermodynamics, which is delta G, G is Gibbs energy, equals delta H. H is the enthalpy minus temperature times delta S, and S is entropy. We're assuming that temperature is constant. Now, to go from here, we're going to make another assumption, and that's assuming that the change in enthalpy and change in entropy is independent of temperature. So the melting point of water is 0 degrees Celsius. We're assuming that the enthalpy change at 0 degrees Celsius is the same at 25 degrees Celsius. Okay, and we'll assume that the entropy change of melting water is independent. So you can melt water at any temperature and the entropy change would be the same. It's not. These do vary with the temperature, but we'll assume they don't. Okay, and for short temperature ranges, we can. Now, I'm going to add a little bit of notation here. Don't freak out. But we're just adding things to make it specific to this problem. So we want the change of fusion, so melting, of Gibbs energy. We want it at 25 degrees Celsius and in its standard state because we're at a constant pressure of 1 bar, and we're assuming this is pure water. And that's approximately equal to the change in enthalpy at 0 degrees Celsius. So even though we want the change in Gibbs energy at 25 degrees Celsius, we can use the change in enthalpy at 0 degrees Celsius because we're assuming it's constant. Minus, this is the temperature, 25 degrees Celsius in Kelvin, times the change in entropy. Okay, now, so we need to solve for this stuff. And to get the change in entropy, we're going to use the fact that at 0 degrees Celsius, the liquid and solid phases are in equilibrium. And if they're in equilibrium, then the Gibbs energy change is 0. And if we plug that into this equation right here, we get 0 equals the change in enthalpy of melting minus the melting point, this is right here, times the change in enthalpy, or entropy, S. If we solve for the change in entropy, we get this expression right here, which we can plug into our equation right here. And now we have everything in terms of the enthalpy. So we can plug in our values. This is our enthalpy change of fusion. It takes energy to melt the water, so we plug that in, and we're left with a change in Gibbs energy of negative 0.550 kilojoules per mole. It's negative, which means it's spontaneous, and a negative Gibbs free energy change means that the total entropy is greater than 0, so it's spontaneous. We can solve for this delta S by using this cool equation right here. Let me know if you want me to derive this. We plug in our values for the change in Gibbs energy. This is positive because this negative cancels out with this negative, and we're left with a positive number, so the entropy of the universe changes when water melts at 25 degrees Celsius. Cool beans. Okay, y'all, hang in there. I know thermo's not an easy course, but the more problems you do, the better you'll get. Good luck on your midterms, final exams, and I'll see you in the next video. Cheers.